For this experiment, you will need a power supply, an electronic balance, an ammeter, a Pasco current balance apparatus, a retort stand, and a number of wires to connect everything up. Now, this Pasco current balance apparatus consists of a bracket that is mounted on the retort stand, and on the end of the bracket is a small printed circuit board, and this printed circuit board contains the wire that we use in the experiment. The apparatus also contains permanent external magnet, which consists of actually 6 smaller magnets. Now, here's the circuit board we will be using in Part A and Part B of this experiment. The wire that actually goes into the external field is the wire on the bottom section of this printed circuit board. Now, we'll measure the length of this wire and include this in our lab write-up. Now, here a ruler is placed on top of this printed circuit board. You can see the 0 of this centimeter scale is at one edge of the wire that will be in the external field. And as we pan across here, you can see that this wire has a length of 4.2 centimeters. Now, this printed circuit board is double-sided, and so the effective length of this wire in the external magnetic field is double that, or 8.4 centimeters. Now, we mount the printed circuit board in the bracket. And lower it into the external magnetic field. Now, in Part A of the experiment, we are going to manipulate the current running through that small section of wire. That wire in an external field will exert a force, and we can measure that force on those magnets with the electronic scale. So we're going to manipulate the current by 1/4 amp each trial and measure the deflection of the magnets as that force pushes down on them. Now, for trial 1, with 0 amps running through that wire, the deflection of those magnets is 0 grams. Now, if we increase the current to 1/4 amp, the deflection of the magnets is now 0.12 grams. So we'll continue increasing the current by 1/4 amp, and each time you can record the deflection of the magnets on the electronic scale. Now here's the last trial at 2.5 amps of current, and you can see on the scale the deflection of the magnets, 1.18 grams. Now with this information and the worksheet that accompanies this video, determine the relationship between the current flowing through the wire and the magnetic force generated by that wire. Now, in part B of this experiment, we're going to use the same wire. We're going to keep a current of 2.5 amps running through that wire, but we're going to change the strength of the external field. And we're going to do that by adding these little magnets to the magnet holder for each trial. Here's the first trial. We've taken out all the little magnets, so there are 0 magnets on the holder and therefore no external magnetic field. We're going to send 2.5 amps of current through the wire and measure the deflection of the magnets. Now each time we add a magnet to this magnet holder, we're going to have to zero the balance before we apply the 2.5 amps of current. Now here's the first trial in part B with 0 magnets in the magnet holder and a current of 2.5 amps of current. The deflection is 0 grams. Now with 1 magnet in the magnet holder and a current of 2.5 amps, you can see the deflection of the magnets is 0.23 grams. Now with 2 magnets in the magnet holders and a current of 2.5 amps again, you can see the deflection of the magnet is 0.50 grams. Now with 3 magnets in the magnet holder and a current of 2.5 amps again, the deflection is 0.73 grams. Now with 4 magnets in the magnet holder and a current again of 2.5 amps, you can see the deflection is 0.85 grams. Now with 5 magnets in the magnet holder and a current of 2.5 amps, the deflection is 1.04 grams. And here's the last trial with 6 magnets in the magnet holder and a current of 2.5 amps. The deflection is 1.17 grams. Now with this information and the worksheet that accompanies this video, find the relationship between the strength of the external field and the magnetic force that the wire exerts.